Hello and welcome to CANNAMAntv. My name is Conor McLeod, and in this extremely informative interview, I speak with Emeritus Professor at Aberdeen University, whose research was responsible for the discovery of THCV, CBD and CBG, and was game to have a Lifetime Achievement Award for cannabinoid research, and is recognised globally as one of the top 1% of researchers cited in the field of cannabinoid study, Professor Roger Pertwee. In this interview, we discuss what led Professor Pertwee into the field of cannabinoid research, the major breakthroughs in cannabinoid research over the years, the discovery of the endocannabinoid system and what this meant for cannabinoid research, the future direction of cannabinoid research, the importance of collecting real-world data, and legal highs and the danger of synthetic cannabinoids. Make sure to like and subscribe, and to support the channel further, please sign up to Patreon, where you could help to build a stronger cannabis media platform for £3 a month. Now then, let's talk cannabis. And to just start off, just go back to when you initially started your research, what was the landscape like, and what was it that drew you to cannabinoid research initially?
Okay, well, I was doing my first degree at Oxford. It was in biochemistry, and while I was doing that, I had the opportunity to become an officer cadet with the Army. And one of the things that met, it was with the Royal Engineers, and so I did a diving course with them and became a qualified shallow water diver. And I learned while I was on that course about a thing called inert gas narcosis, how air at high pressure can make you feel drunk,
right,
and so on, which is dangerous for divers, which is why they don't breathe air beyond a certain depth. I thought, oh, I'd love to do a PhD on that. So I looked around, and back in Oxford, there was actually the professor of pharmacology there who specialized in anesthetics. And he took me on to study the effects of diving gases and their anesthetic effects particularly. And so I did that, and I got my PhD, no problem, or DPhil as they call it in Oxford. And then he asked me if I'd like to stay on to do a postdoctoral research on cannabis. And his hypothesis was at that time, and this is really early days in the field of pharmacology of cannabis, very little was known about how it worked and how the constituents worked. And he thought maybe, just maybe, they may act sometimes by acting like anesthetics to interact with membranes, particularly on nerves, to alter the fluidity of the membranes in a way which would produce the changes we see. So that's something I got into. And that gave me a chance to start working on the pharmacology of cannabinoids. So I switched from biochemistry really to pharmacology at that stage. And also for my PhD, which was the anesthetic thing. It's very exciting. It was very early days. This is in the late 1960s, early 1970s. And really the THC, the structure of it had only recently been discovered. THC, the tetrahydrocannabinol, the main psychoactive constituent of cannabis. One of the things we did was to explore the constituents of a dark green liquid called tincture of cannabis, which was actually an approved medicine in the UK at that time. It was a dark green liquid, which was really cannabis dissolved in alcohol, actually. And that was given to patients at that time for pain relief and so on. And so we had the opportunity to see what was in that green liquid. And with THC, we found in there, of course, this was in collaboration with medicinal chemists who did the analysis of that. And another one we found was a thing which we may come back to later called THCV, tetrahydrocannabivarin, which is structurally very similar to THC. I also had the opportunity to develop bioassays for measuring the effects of drugs like THC. And I also, and one of the things I did was to explore how it affected thermoregulation, the ability of animals to control their body temperature. I'd found for anesthetics that at very low doses, they actually lower the thermoregulatory set point so that animals choose to live at have a lower body temperature, which they then regulate as per normal, just about 3 or 4 degrees below normal. And very interestingly, I found that THC did exactly the same thing. It lowered the temperature, and I was able to show it actually was acting on the hypothalamus, which is part of the brain involved in thermoregulation, to lower the set point. So it didn't stop animals thermoregulating. It just meant that if you gave them THC, they for a short time produced less heat and lost more heat through their skin by vasodilation of blood vessels in the skin. Their temperature went down, and then it settled at about 4 degrees below normal, and then they thermoregulated normally again. And behaviorally, I've developed and built an apparatus which allowed the animal to choose between a warm and a cool environment. And when I gave the animals THC, they rushed into the cold and their temperature went down. And then they fluctuated between the warm and the cold, keeping their temperature, the body temperature, about 4 degrees below normal. So that was one of the earliest things I discovered. And the other thing I developed was an assay for measuring the effects of THC on motor function, particularly on a thing called catalepsy. What happens with cannabinoids like THC is if you give them to, say, a mouse, the mouse goes into a state where it goes totally inactive for short periods and then moves around normally and then goes totally inactive again, goes into a trance-like state. And I built, the apparatus I built was a metal ring on the end of a stalk, and about 6-8 inches high stalk, and put the mouse on the ring, and the mouse would retain its ability to grip, would wander around on the ring, and then go off into a trance-like state where it would suddenly stop moving, maybe lying across the ring, or maybe even hanging from the ring by its forepaws, but totally inactive, and then it became active again. And the bigger the dose, the bigger the proportion of time the animal remained in that state. So that was quite a useful assay. And in fact, we were able to, we and others in the cannabinoid field came up with 4 assays in which THC showed equal potency. And it was only cannabinoids which seemed to do that. Other drugs, they might be active in one or other of the tests, but not in all 4 with equal potency. And so that became what was called the Tetrad Assay, as a way of telling whether a new drug or synthetic drug that had been developed was behaving like THC or not, if it was, depending on its activity in that Tetrad Assay. Well, that was all in the 1970s, really, and late 1960s, 1970s, and beginning of the 1980s as well. What happened was, though, in 1974, actually decided I needed to get I was living on grants up to then as a postdoc, and I thought I'd better I had got married, and I thought I'd better get a permanent job. So I looked around, and the lectureship came up here in Aberdeen, and so I applied for that and got it. So I moved up here in 1974, but I continued my work on cannabinoids, and which was great. And in fact, I developed another assay there, which I really borrowed from another group working in Aberdeen, led by Hans Kostlitz, who actually discovered what are called the endorphins. These are naturally occurring opioids which are produced in our bodies, and they were discovered by him in Aberdeen and his group. But they had a particular assay called the mouse vas deferens assay, which is the vas deferens of the mouse in an organ bath. And if you stimulated it electrically, you caused transmitters to be released from nerves, which then produced contraction of the muscle. And I thought, well, just maybe that might work for cannabinoids as well. So I tried it, and THC indeed was active in that assay. And that was a really, we published on that, and that was really successful, I think. And that prompted a friend of mine, Raphael Meshulam, who was based in Israel, to contact me to say, would I like to test a compound he'd extracted from pig brain? And his idea was that maybe, just maybe, we produce cannabinoids in our own bodies. And that idea was prompted by the discovery in the late 1980s, early 1990s of cannabinoid receptors, receptors for cannabinoids like THC, which are present in our bodies, present mainly on nerve terminals, the CB1 receptor anyway, which was the first one to be discovered, present mainly on nerve terminals. So we thought, well, if we have these receptors, why do we have them? Surely it's not to get high on cannabis. There must be some other reason for it. And so he looked around for a chemical and came across one in the pig brain, which he thought might be a cannabinoid. So he sent it to me to test to see if it behaved like THC in our assay. And indeed it did. It behaved just like THC. At that time, we didn't have what we call antagonists of the CB1 receptor. There weren't any specific drugs around which would block CB1 receptors. But what I did do was, following on from that first experiment, which we set of results which we published in Nature in 1992, was to make the mice tolerant to THC, and then see if in the assay they were tolerant also to anandamide. And I found that they were. So made the mice tolerant to THC, they were also tolerant to anandamide. So that suggested that the anandamide was acting on the CB1 receptors in the vas deferens. And subsequently, we were able to show that that was indeed the case using a selective antagonist for CB1 receptors, which was developed. The first of these, I think, was developed by a drug company called, it was called Ramonabant, or SR14, 17, 16A, developed as an anti-obesity agent, but was a very selective CB1 antagonist. And so that was very exciting. And that really opened up the field. The field was in the late 1980s was beginning to fade a bit because all the obvious things have been done. But suddenly with the discovery that we have not only receptors in our bodies, and there are at least two kinds of cannabinoid receptor, CB1 found mainly on nerve cells, and CB2, which are found mainly on immune cells, and so on. So what discovery of those receptors, and that we have endogenous compounds which can target those receptors, really opened up the field. And as it turned out, endocannabinoids seem to have an important function for our health, and they're released in a way which is usually beneficial to our health. One interesting one is they're released in the part of the brain called the in a part of the brain which is involved in controlling our memory. And for example, and what they do is they're released in a way which reduces the memory, so you forget things. And interestingly, there's evidence that particularly bad memories. So if you have bad memories, bad experiences, it helps you to forget those bad experiences. For example, if you've had a bad dream at night and you wake up, that memory of that dream fades very quickly, and that's the endocannabinoids being released in the brain to do that.
That's quite interesting, actually, Professor, because I've always wondered that I've came across that before, and like it's almost. Would you be able to explain how that's possible? How would they be able to sense how can they differentiate a bad memory from a good memory?
I think it's stress does it. So I think the endocannabinoids are released more in stress in a protective way.
Right.
Yeah.
And if you were to generalize as well, just for everybody, obviously people will be aware what the endocannabinoid system is, but if you were to articulate the nature of the endocannabinoid system, what would that statement be?
The nature of it? Okay, so what it consists of are chemicals. The first one to be discovered called anandamide. We call that, ananda is the Sanskrit word for bliss or happiness, internal bliss or happiness, so we called it ananda. And it's an amide, so we called it anandamide. So the endocannabinoid system consists of these chemicals, and they're not stored in the brain. They're only synthesized when they're needed. So they're synthesized on demand and then released mainly from nerves to act post-synaptically. They tend to reduce release of other transmitters, which is because CB1 receptor, it tends to be at nerve terminals and tends to reduce release of other transmitters. And so that's their role there, and they're released, as I say, in a way which is protective. For example, probably to stop us getting too fat. So if we are eating too much, they're released to stop us, to reduce our appetite for food and that sort of thing. And the endocannabinoid system then consists of those chemicals which can target cannabinoid receptors, and the other part of the system then are the cannabinoid receptors, the CB1 and the CB2 receptors.
So you mentioned the anandamide obviously is very similar, if not identical, to THC. Are they molecularly similar, and are they essentially interchangeable?
Sorry, similar to what?
The anandamide and THC, are these molecularly similar, or are they structured differently?
No, they're structurally quite different. Yeah, structurally quite different. Of course, THC is from the plant; it's naturally occurring, but only not in plants. We don't produce THC ourselves, but we do produce anandamide. But the structure is such that they can both target the same receptor.
Right. And how does THC and TCV differ?
Okay, so THC and THCV are structurally very similar. They're both produced by the plant cannabis, by cannabis. They differ simply in that THC has what's called a side chain, 5 carbon side chain, and THCV has a shorter side chain, and that's the only difference between the two compounds. But but it has makes pharmacologically important because it means that THCV essentially doesn't activate CB1 receptors, but tends to block those receptors. So it can still bind to the CB1 receptor, but in a way which results in blockage of that receptor. Whereas THC is an agonist, it can activate the CB1 receptor. It's not a full agonist, it's not very strong agonist, but it can, it's what's called a partial agonist, but it has enough efficacy to produce signs of activation of CB1 receptor. And then both CB1 and both THC and THCV can activate CB2 receptors. So they share that ability. But at CB1, they have these opposite effects.
So pharmacologically speaking, THCV and THC serve different functions?
Well, they don't, yes, they have different pharmacology, but they're not found, they're not produced in our own body. So we don't have any physiological functions at all. It's all pharmacological.
So the difference as well between CB1 and CB2 receptors, is there a side point actually? Do you think there is a possibility of finding other CB sites?
Yes, the cannabinoids don't just target CB1 and CB2 receptors, they have other sites as well, a large number of other sites. THC, for example, has many other sites. I'd have to look up to tell you which the specific ones they were, but it has many other sites. And that makes it, it gives us a unique pharmacological fingerprint in that other drugs which can target CB1 and CB2 won't necessarily have all those other actions as well. So they will be different, although they will share the ability to target CB1 receptor.
And at what point, I think, do metabolic enzymes come into play? Monoacylglycerol and fatty acid hydrolase, are these like crucial in the regulation of the endocannabinoid system?
Absolutely. So the endocannabinoids are synthesized on demand. So there are enzymes which catalyze the synthesis of those compounds, but there are also enzymes which catalyze the metabolism of them. So for anandamide, that's mainly fatty acid amide hydrolase, and for another endogenous cannabinoid, 2-arachidonyl or 2-AG, that's monoacylglycerol lipase, MAGL. So they're very important because they stop the effects of endocannabinoids after their release. Interestingly, there are genetic disorders for those enzymes, which can result in them not working so well. For fatty acid amide hydrolase, for example, that results in higher than normal levels of anandamide in the body. And interestingly, there was something in the newspapers recently, a year or two ago now, and it was also featured in a review in an article by a scientist, authored by scientists. There's a lady in Inverness, and I don't know if you've come across this before, but there's a lady in Inverness, and she has problems with her fatty acid amide hydrolase. She's genetically modified in a way which means she has higher than normal levels of anandamide. And she says she feels very happy-go-lucky. Presumably she's feeling a sort of high-like effects of cannabis, if you like, because of the anandamides not being broken down as normally happens. And she also feels very little pain, which is in her case very good because she has very bad joints, and she would normally have severe joint pain, but she doesn't have pain. It's pain, of course, is a mixed blessing. It's in some ways it's bad, but in some ways it's protective. And what it does mean is sometimes she smells burning meat in the kitchen. It's her burning.
Oh, geez, yeah.
She put her hand on the stove and she's burning her hand,
yeah.
And she smells that, but doesn't feel the pain. So she doesn't know she's done it, except for the smell.
Yeah, I think I did actually see that.
Yeah. Yeah. So the endocannabinoid system, I think, is a very important system in our bodies.
Yeah. I mean, when people take, I think very often, because CBD is the most prevalent, obviously, cannabinoid mainstream at the moment, just because of the popularity and it's hitting the high streets and stuff like that. And very often there's this confusion, I think, when people talk about that when people consume CBD, it's actively interacting with CB sites. Is that accurate, or does CBD just naturally raise endogenous cannabinoids to an efficient level?
CBD has its own pharmacological actions. It does target cannabinoid receptors, but opposite to THC, it actually reduces the activation of CB1 and CB2 receptors. It's probably doing that by targeting what are called allosteric sites on those receptors. Now, the receptor has at least two sites on it, orthosteric sites. These are sites which are targeted by straight agonists like THC and Anandamide and so on, causing an activation. But it also has orthosteric sites. And these are sites which, if you target those and if you activate those, it strengthens the activation of the orthosteric site by an agonist or weakens it. So it can turn up or turn down the volume, if you like, of resulting from activation of the orthosteric site. Cannabidiol seems to be a negative allosteric modulator at CB1 and CB2, so it can reduce the activation of CB1 and CB2 receptors at the orthosteric site by acting on the allosteric site.
So do you think is that what happens, do you think, when individuals gain a tolerance towards cannabis use, that it's overactivating the orthosteric sites?
So tolerance, yes, tolerance is if you go on activating CB1 receptor too long, when you get tolerance developing. That's right. Yes. Yeah.
See, this is absolutely fascinating, this, because there is such a diverse direction in which can go down. I mean, even when you mentioned at the beginning of the 90s, when it was essentially established that we have an endocannabinoid system, and then I think it was roughly 10 years later, Dr. Ethan Russo had articulated an endocannabinoid system deficiency. I mean, how far on since the beginning of the 2000s, beginning of the noughties, really, has cannabinoid research came?
Since when?
Since the beginning of the 2000s, since essentially the articulation of endocannabinoid deficiency.
Okay, I think there's been a lot more interest in the therapeutic potential of cannabinoids and of targeting the cannabinoid system in various ways, and of exploiting the presence of interesting compounds in cannabis as well. One of the interesting discoveries was one which we were involved with, which was the discovery of the allosteric sites, which I mentioned just now. And there are allosteric sites both on CB1 and CB2. We worked with a compound which behaved in a way which suggested it had to be an allosteric modulator. This was a compound I got from a drug company, actually, but we didn't know it was allosteric, nor did they. It turned out that it was behaving allosterically, and that led to the, as I say, discovered that there are these allosteric sites, and they, I think, we've studied those more. They're very interesting targets for new medicines, I think. And I've been working with various medicinal chemists, and we've come up with synthetic compounds which can target those allosteric sites, mainly acting as positive allosteric modulators, so they can strengthen the activation of the CB1 receptor or the CB2 receptor. And strengthening the activation of CB1, we obtained evidence in collaboration with other groups that can result in pain relief, and presumably because it's enhancing the activation by an endocannabinoids of CB1 receptor, and it can also reduce pressure in the eye if the pressure has been raised. So in other words, they might be good for treating disorders like glaucoma, which is excessive pressure in the eye. But we've only done so far preclinical data that's work with animals, and it remains to be seen whether that would work in the clinic. So, but it's an interesting direction to go down, I think.
Yeah. One of the things, I think it was relating to the THCV, if that's correct, yeah, THCV, and it's the potential THCV has in treating things like Parkinson's, stroke, obesity, and other dementia-related conditions. Could you talk a little bit about the efficiency of THCV, in particular towards dementia?
I'm not so sure about that. I'd have to look it up, quite honestly. But one of the interesting possibilities for THCV is that because it blocks CB1 but activates CB2 at the same time, it might be good for treating kidney disorders linked with diabetes, and might be good for treating diabetes. It's a disorder called renal nephropathy, and it could be that THCV would be good for that. But that's something we haven't yet, we're still investigating. We haven't yet come up with an answer to that question of whether it would work for that.
You mentioned synthetic cannabinoids. One of there's a bit of a disagreement in the CBD industry, really, about the the push for predominantly synthetic cannabinoid products opposed to full spectrum cannabinoid products. And what is your personal opinion on the level of interaction physiologically, or the difference between a synthetically induced ingested cannabinoid or a phytocannabinoid?
Well, it depends. If the phytocannabinoid medicine is pure CBD, then it's really going to be the same as synthetic CBD. But there's a good chance that other phytocannabinoids will be in there, and non-phytocannabinoids will be there to some extent if it's extracted from the plant. And that might be good or bad. Some of the other constituents might actually contribute to the beneficial effects of the cannabidiol. We don't know. It's interesting, though, that one of the successful medicines, or a couple of them to be developed, one was developed for treating multiple sclerosis and so on, a drug called Sativex, and that was developed by GW Pharmaceuticals. And that's really contains cannabidiol and THC together in around equal amounts, with the THC extracted from THC-rich cannabis and the CBD from CBD-rich cannabis, and the two are mixed together to form the product. And interestingly, it's given through a spray to the mouth, which means it's absorbed from the mouth, you don't swallow it. The idea is not to swallow it. And from the mouth, it'll go straight to the heart and to various parts of the body. If it's swallowed, then the CBD and the THC go first to the liver, and that may be not so good because it'll affect liver function much more. So it's quite good if it's absorbed in that way. And another one they developed was Epidiolex, which is cannabidiol, again extracted from cannabis, and that's for treating certain kinds of epilepsy. And that seems to be a good way forward.
So in your research, have you identified the impact of an entourage effect with the multitude of cannabinoids when an individual ingests them?
We tried to do that at one time, and it didn't get very far with it, and something that I really would like to get back to. Yeah, right. To indeed, absolutely.
What was the reason for it? You didn't accumulate too much? Was it just a time frame on research? Was there not enough funding?
It was just we didn't come up with anything. We probably did the wrong experiments. That's research for you, you know.
It's very humble to say that, to be honest.
No, probably used the wrong assays maybe, but I think there is an entourage effect, that's for sure. Yeah, that's right. That said, I think there's a place also for synthetics. I mentioned one example already, which is the drugs which are allosteric, but there are other examples as well. One actually is a synthetic analog of cannabidiol. Now, cannabidiol, one of the effects we discovered it has is it can reduce nausea, it can reduce vomiting, and so it might be good for treating for cancer chemotherapy, to reduce the nausea and vomiting that can reduce. And it also reduces anxiety. But what we did find very interestingly was that cannabidiolic acid behaves like cannabidiol, but is more potent than cannabidiol. Now, cannabidiolic acid is also in cannabis. It's a precursor of cannabidiol. So cannabidiol is formed from cannabidiolic acid in the plant, particularly if you heat it. So we found cannabidiolic acid worked even better. It was more potent, but both the compounds have what's called a bell-shaped dose response curve, which means they work at a particular dose. But if you lower the dose, they don't work. And if you raise the dose, they don't work. So they're just a narrow range of doses in which they work. And that range is broader for cannabidiolic acid than cannabidiol. The problem with cannabidiolic acid is it's not very stable. Right. And that resulted in the idea of developing a stable analog of cannabidiolic acid synthetically. And we did that. It's got the cannabidiolic acid's got a carboxyl group on it, COOH, and we methylated that to form methyl COOH, so methylated cannabidiolic acid, and that was a compound developed by Raphael Meshulam in Israel, person with whom I'd collaborated before for the Anandamide experiments. And we tried that, and that actually worked even better than cannabidiolic acid. It had a broader bell shape, and it was a bit more potent. So it could well be that that synthetic compound might be better than cannabidiol or cannabidiolic acid at treating nausea and vomiting of chemotherapy, and also reducing anxiety. And it's interesting that, in fact, a group in Brazil had already shown that cannabidiol can produce signs of anxiety relief in humans. The assay we used actually used healthy people, but the assay we used actually was public speaking anxiety produced by public speaking, which was very nice. And they found in the subsequent paper that in fact its dose response curve was bell-shaped, just like we found. Now we actually went on to discover that the CBD and then the CBD acid and then the methylated compound, they actually are acting by targeting serotonin receptors in the body. So we target 5-HT1A receptors. Serotonin, of course, is an important transmitter in the brain. It acts on its own receptors, and the cannabidiol, etc., strengthen the activation of those receptors by 5-HT or serotonin. So that seems to be their mode of action. And it's interesting that may also be the case in the human study, because they did a human study which also involved a synthetic compound which can activate 5-HT1A receptors.
That's quite interesting, because often, I mean, just we mentioned the serotonin impact from cannabinoid use, individuals who have spent years or sometimes decades consuming cannabis daily, what's been noticed very often is a observable consequence of withdrawal is behavioural orientated. So sometimes there's very often research which indicates a very temporary bipolar response to overconsumption. And one of the things that I always wondered was, I was like, if these receptors are getting continuously, the way I think about it, it's kind of like a path. So if somebody's continually walking down on the path, there is no life that grows there anymore. But once you stop walking down it, inevitably it starts growing. Do you think that's a relatively accurate analogy, that the receptors can become overused, and as a result of that, people shouldn't kind of overuse cannabis? It should be used moderately, obviously.
Oh yeah, I think so. Yeah.
It's really quite fascinating as well, Professor, because one of the things, like from when you first started doing cannabinoid research, and then beginning of the 90s, the endocannabinoid system becoming established, from on the ground as a researcher, what was it like? Was it kind of like this what was it, like Pandora's box that opened, that you like really were overwhelmed by the amount of directions that you can take?
Oh, absolutely. Yeah, no, it's very exciting. Yeah, very exciting. As I mentioned, we'd really done all we thought we could do with cannabinoids back in the late 1980s. But then with the discovery of those receptors and then the endocannabinoid system as well, even the receptors by themselves, discovery of that would have made a big difference, because suddenly we had important targets, especially as those receptors are present on nerves and so on, with the CB1 on nerves, CB2 on the immune system. So that opened things up quite a bit. But then when we discovered that there were endocannabinoids as well, endogenous cannabinoids, that made a huge difference, because suddenly there was an awful lot more research to do, because we had to, why on earth do we have these receptors? Yeah. And why on earth do we have these endocannabinoids? What are we doing there?
I think at present, that there's been an established, 120 odd cannabinoids, I think. And at the moment, I mean, how, from a research perspective, is there still, I mean, is it just mainly in the dark? Are we only familiar with primary cannabinoids, and where do you think the direction will go?
Oh, I think it's going to be very important to explore the pharmacology of all those phytocannabinoids. So there's over 120, as you say, phytocannabinoids which have been discovered in cannabis, and of course it has other compounds in it as well. But it's got these phytocannabinoids. It's a family of compounds like THC, cannabidiol, etc. We looked at another one we've looked at is cannabigerol, and we found interestingly that it can target adrenoceptors in the brain, so it can activate adrenoceptors, receptors which are activated by adrenaline, right. And in a way that can produce pain relief. So it could well be that cannabigerol could be used to relieve pain by targeting those receptors. It's less strong than some of the other compounds which are already known to be able to do that, but those ones which target the receptor more strongly have side effects, and it may well be unwanted side effects, and it may well be that cannabigerol might be better because it's weaker, and so may avoid some of those side effects.
What relationship do you think, obviously you mentioned obviously other compounds, obviously including terpenes and flavonoids and other fatty acids, which are obviously in amongst the group. What relationship do these individual compounds, terpenes, flavonoids, have with cannabinoids and their efficiency to be therapeutic or medicinal?
I don't know. I think that's other people might know that more than I do. It's not something I've looked at, but it's certainly something that needs exploring. And indeed, it may be some of those compounds which are involved in what you mentioned earlier, the entourage effect.
Yeah,
That's right.
It is very exciting.
Yeah,
so, at this moment in time, what do you see as the most exciting direction forward for cannabinoid research?
Oh, well, I'm biased, of course, but I think the allosteric modulators, I think, are really very exciting because they can, in a selective way, by targeting CB1 or CB2, they can strengthen the beneficial effects of endocannabinoids, which are usually, but not always, released in a protective way. And so they could strengthen that protection and without producing unwanted effects, side effects. The alternative way, it would be to block the metabolism of endocannabinoids so that you boost their levels. But you have to bear in mind that endocannabinoids can also have other pharmacological targets. And so it wouldn't just be if you just boost their levels, you will also increase the activation of those other targets for good or ill. It might well be for good, but it might not be. Whereas the allosteric modulators, if they're just selective for CB1 or CB2, they're only going to strengthen the activation of those receptors by endocannabinoids. We have to bear in mind, though, that as far as synthetics are concerned, it's not always good news. One other example, by the way, of good news is a drug which was developed in USA recently, which is a THC analog, which is water soluble. So we added a huge trouble with the phytocannabinoids is that they're very fat soluble, but not water soluble, so lipid soluble, but they don't dissolve in water. So it makes it difficult to give them. You need to give them in the vehicle of one kind or another. Whereas the compound that these people developed was water soluble form of THC, and it was what was called a prodrug, which means it wasn't active like THC. But they gave it to an eye into the eyes of rabbits, which had high blood pressure high pressure in their eyes. And when they gave it to the rabbits, it lowered the pressure in the eyes, suggesting it might be good for glaucoma. What's happening there is this prodrug, which is inactive, once it gets through the eye, breaks down to THC, which then works. So that's another interesting example of a synthetic strategy.
That's fascinating, because very often I think people don't consider that. I mean, essentially the lipid-based element there is the carrier oil. That's what we're describing.
Yeah.
And with the water soluble, that essentially removes the need for any carrier oil. You can just give it directly to the individual requiring it.
That's right. And then, as I say, it's not active itself, but it breaks down once it gets to the site of action. It breaks down to form THC in this case. Of course, with synthetics, there's bad news as well as good news, as I mentioned earlier. One example is I mentioned rimonabant earlier, or SR14-1716A, the first antagonist to be discovered for cannabinoid CB1 receptors. And that was developed as a medicine by a drug company for treating obesity. And it worked very well. And in fact, it had clinical trials and was approved and became a medicine. But a few months later, had to be rapidly withdrawn from a clinic because it produced suicidality. Right. It caused some patients to kill themselves and it made them feel very, very depressed. And so things don't always work out as you might hope.
No, certainly not.
No.
You mentioned there the clinical trials. How inhibiting is the clinical trial format for really highlighting the efficiency of individual cannabinoids in the context of an entourage effect and stuff like that?
I think now clinical trials, it is much easier now for drug companies to perform such trials. Governments have changed their attitudes to cannabis, which was at one time was very negative, but then it gradually changed. One thing which helped change it and led to actually the development of the drug for multiple sclerosis, or helped with it, was self-medication by people. And there was a lady in the UK who used to write articles about how she took cannabis to relieve her multiple sclerosis. Her name that she used in the paper, not her real name because she didn't want to get arrested because it was illegal at that time to take cannabis, but she took it and it worked very well for her. Claire Hodges, she called herself. And I managed to get in touch with her and talk with her. And she was a member of a large group of patients who self-medicated. So what we did was to send out, me and some colleagues, collaborators, send out questionnaires to these patients. And through Claire Hodges, she had the addresses of these patients. They then replied to us directly, and we were able to publish what they said about cannabis for multiple sclerosis in a peer-reviewed paper. And what they claimed was it reduced their pain, it reduced their spasticity, improved their quality of sleep, for example. And that really, I think, encouraged the government, certainly in the UK, to change its attitude and say, well, okay, we think it would be a good idea to carry out clinical trials to see whether this is true or not. And that was done, and it worked well. And very, very amusingly to me, because this was back to front in a way, we then went on to do basic research, scientific research, which also showed that in an animal model of multiple sclerosis, there's work done in collaboration with a group in London, that the cannabinoids work very well. So the starting point was the patients who self-medicated. Next step was clinical trials, and it worked in that. And then very finally, we went back and did the science. Whereas usually it's the other way around. You start with the science and then work forward from there.
Yeah. That's good. That's quite amusing.
Yeah. But I think the patients actually are who self-medicate with cannabis, or actually are carers of other people, and give them cannabis. I think they're very good sources of information.
Yeah.
Another example of that was a lady, and there are several of these ladies, I think, but I'm thinking one in particular, who used to go to the Netherlands to get cannabis oil, and give it to her son, very young son, who had epilepsy. And he had terrible epilepsy, and he used to wake up in the night screaming and convulsing and so on. Dreadful. And she found that the cannabis oil worked very well for that.
Yeah.
And that encouraged the government. She talked with the government, and that encouraged the UK government to change their attitude again to cannabis, to say, okay, we agree that clinical trials, it should be possible for doctors to carry out clinical trials with cannabis.
Yeah. It's 100% agree, and I think like things like Project 21, which are collecting thousands of first-hand accounts of cannabis use through patients in Europe, are really helping towards push this forward. And but the thing that kept popping to mind there when you're mentioning that is real-world data, which is essentially the accumulation of that, people giving their first-hand accounts of their own cannabis consumption and the response it's had. Going back to the research thing, sometimes I think, do you think it'll be? It seems almost like it'll be thousands of years yet before we accumulate a fully enclosed archive of cannabinoid knowledge with the randomized controlled method, because of the diverse interactions. So I mean, obviously the isolating individual cannabinoids and testing their efficiency is one direction, but very often the efficiency will be determined based on the unison of other cannabinoids. I mean, do you think that there will be a more innovative method of judging the interaction on an entourage basis, or do you think that this is the method that we have of randomized controlled trials is staying with us, and this is how we're going to have to do cannabis research?
I think it's the trials are the right thing, but of course it would be very interesting to get information from people who self-medicate.
Mm-hmm.
And to find out a bit about what particular form of cannabis they take.
Yeah.
And maybe to be able to, from that, unravel some information or some evidence that it might be an entourage effect. Sometimes it might, for example, if they can find out more about the product they're actually taking.
Yeah.
The trouble there, I guess, is that might be quite difficult, and it could be that if they get their cannabis from a particular source, it may be variable. It may not always be exactly the same. But it would be interesting maybe to set up a system where the different products actually are tested by scientists to see what they contain, and then it'd be interesting to link that with the claimed benefits of those different products. we might then find that might reveal that a product which contains more of one particular or two particular chemicals works better than the one which doesn't, maybe.
I'm setting up a GoFundMe, and we're going to do that.
But I think that would be quite interesting to do, I think.
That would probably be one of the best approaches, because it does seem from the outside looking in, obviously by no means, I'm not even close to a researcher. I struggle reading over your credentials, quite honestly. But I do think that it seems to be an inhibiting factor when you've got such a diverse spectrum of product that's available. And then, as we mentioned, the endocannabinoid system being varied. It just seems to be that there's an inhibiting element of research when it comes to isolating particular cannabinoids, testing their efficacy, and then moving forward in that direction. It just seems like there'll be hundreds of years yet before we get the information that's required. Yeah.
Which is why I think one can speed things up a lot by listening to the people who self-medicate, because okay, we won't get all the answers, but we get some important answers. We can come up with new medicines for disorders which are badly dealt with by medicines we now have. That would be very good, I think.
Yeah. Well, I've essentially covered everything I would like to discuss. Is there anything else you would like to mention before we kind of get going?
There's one thing I was just trying to think what it was. Oh dear.
I think one of the talking points.
Oh yeah, synthetics.
Perfect. That's actually exactly what I was going to say. Perfect.
Yeah. The other thing is the dangers of synthetics are drugs which are much stronger than THC at activating cannabinoid receptors, CB1 receptors. And these were drugs which appeared on the websites and people could buy them.
That Spice and Legal Highs, was it one of them?
That's right.
JWLL or something?
JWH. Now, JWH is John W. Huffman.
Right.
And he was a great friend of mine. And he is actually a synthetic chemist. And he's a researcher. And he developed lots of synthetic compounds like that one, but for research reasons. And they formed very important research tools for studying cannabinoid receptors and the consequences of activating those receptors, et cetera. But what happened was, of course, he published his results in quite legally in journals, which included a description of how you make these compounds, which meant that anyone could come along who's a chemist and could then make them. And that's what happened. And these people made them and then sold them on the web, but called them by those names. And there were other friends of mine who did the same thing happened to them as well. They had their compounds being sold on the web. And trouble is those designer drugs, as I call them, really a bit dangerous because they activate the CB1 receptors so strongly and with such high potency. And a lot of people who took them died actually as a result of that.
Yeah, that's right. I have unfortunately engaged and consumed a couple of those products over the years, and they're not pleasant at all. They don't respond in the same way as cannabis. That it's very alien and yet very similar.
Yeah. It's just very strong.
Yeah.
So they have a much higher maximal effect.
Yeah.
So
it's
THC,
horrible, quite horrible.
Yeah. THC is what's called a partial agonist, which means it can produce a dose-response curve. So as you increase the dose, the response gets bigger, but then it reaches a peak and doesn't go any higher. And the height of that peak is much lower for THC than for a full agonist, like some of these designer drugs, which have a much higher ceiling, and that's the problem.
Yeah. So in the future, I really hope, do you think that an increased availability of legitimate cannabis and like a decriminalization approach or something like this would help to, we've essentially seen a decrease over the years of these synthetic substances, but to remove them completely, do you think it'd be a good idea to just obviously look, individuals are consuming cannabis related products anyway, why not just push through the real deal?
Well, I think the way forward is maybe to work in the same way as has been done for alcohol. And so you have approved products, and those products have to be approved before they can be sold. But only approved products can be sold. So they have to be licensed products. And I think that's the way. And so if people sell other products which are not licensed, then that's illegal.
Yeah.
And also you'd have to have a license probably in order to sell those compounds.
Yeah. I'd fully agree, Professor Pertwee, honestly. And interestingly, just before we get going, one of the things where I have a conversation with my dad about this kind of thing often, and about the Royal Horticultural Society and how they're going to have to come along, and because there's such a diverse spectrum of cannabis plants out there, and yet very often one strain and another strain, even though they're named differently, will be the difference will be negligible at best. And so he has this proposal where he thinks that the RHS are going to come along and go, right, that's a real plant, that's a real plant. Do you think that would be a possibility?
Well, I don't know. I think you need to go to the bottom line and say, if it's safe and it's okay.
Yeah.
But it has to be approved. It has to be so it fits in with regulations and so on. The other thing, I think, you need to have an age limit as to when people can buy these products. So younger people shouldn't be allowed to have them. Yeah. Well, certainly not THC containing products. Whereas it might be okay to legalize THC containing cannabis for older people.
Yeah.
So that they can get high, like in the same way that people get high on alcohol.
Yeah.
But adolescents shouldn't be, and young adults shouldn't really be allowed to take THC containing cannabis because of the way it affects the development of the brain.
Yeah, I fully agree. One of the, obviously, very often research that pops up and has done in the past about the interaction between THC and adolescent cannabis use obviously has a negative impact in the long term as a result of that. Unfortunately, let's say I started consuming cannabis at 13 years old. Unfortunately,
right.
Yeah, exactly. And one of the things I've found is, I don't know, it's like, when I look on these things, I see what they mean, but at the same time, I think there's so many additional variables: socioeconomic status, home life, and the genetic susceptibility of the individual anyway, to when they're consuming cannabis. But I think that there's so many different variables. I think it's better to just avoid the potential landmine of that, and just even sometimes I question. I think, is 18 still too young? Is 20? Because when you think about the brain development, obviously neuroscience shows this, that we're not really, the brain never stops developing at any point in time. They're different transitions of the brain, and I think because of things like the prefrontal cortex, one of the things when it apparently, according to what's his name, the biological, I can't remember his name. He's quite a famous dude, I can't remember, but he's essentially said the prefrontal cortex doesn't become active until you're 25, 26. Therefore, it's influenced throughout your life depending on the external factors, so such as obviously consumption of particular narcotics, and that could be a potential hazard. Personally, like, I don't really think it's had a negative impact on my life. When I think about the level of creativity and the level of productivity that I've had as a direct result, potentially of cannabis, but also genetics, all these different things, I think it's better to just play it safe, and just make sure that it's at least 18.
Yes, I think even probably even older, probably in the early 20s.
Yeah, 21. That's what I was thinking, because your brain's still so pliable. 18.
Yeah. I think so. And of course, so you're lucky, but you're just N of one, and equals one.
Yep.
And there'll be others who, if they'd done exactly the same as you, might not be so lucky.
I have names popping to mind right now.
Yeah.
I do, I really do. But this is Professor Pertwee. This has been an absolute pleasure. Thank you so much for your time.
Oh, so fine. I enjoyed it. Yeah, I always like talking about cannabis with people. It's good fun.
Thanks to Professor Pertwee for giving me his time, and thanks to you for sticking around until the end of the video. I sincerely hope you enjoyed the content. I'll see you next time.